Hi everybody, sorry my phone filled up with storage, so I had to start this over again. So when I was last speaking, I was talking about a third way to solve this problem. We're in problem 10.7. We're trying to turn this wrench, and we've already solved this problem twice. We're trying to use a third method now, which is the vector product method. For this method, we're going to use our vector definition of torque. Torque is R cross F. And I was just talking about the right-hand rule where we can figure out the direction of this torque vector as being point my hand in the direction of R, curl my fingers in the direction of F. My thumb now points out of the page, so my torque is out of the page. Okay. To use this definition of torque, we can recall back to chapter 1 when we first learned about the vector product. And we learned to find that the magnitude of our vector product, which is what we're looking for, the magnitude of our torque, we have to find the magnitude of R times the magnitude of F times the sine of the angle between them. Okay, so we know R, that's this distance, that's 0.25 meters. We know F is 17 newtons, but we need to figure out what phi is. Okay, phi is the angle between these two vectors when they're drawn tail to tail. So I'm going to actually move F. So this is actually obviously the way we should draw it typically, because this is how it's this force is being applied, and this is showing us that there is a torque because we have a force being applied at some distance. But I can move F around just for calculation purposes, and so if I draw F right here, now I've drawn these two vectors tail to tail. F and R now tail to tail. So the angle in this equation is talking about this angle. Right, that's phi. Okay, so that's what we need to plug into this equation. To figure this out, I know that this angle is 37 degrees, and so that tells me that this angle is 37 degrees, and from here to here must be 180 because I have a straight line. So that tells me that this angle, phi, must be equal to 180 minus 37 degrees, or 143 degrees. Okay. Now that I know about that, I can just plug into this formula again. So R is again 0.25 meters, F is 17 newtons, and I have sine of 143 degrees. Okay, and throwing that all together, I again get the same answer. So my torque is equal to 2.56 Newton meters. Okay. So that's part A, done 3 different ways. I'm going to very quickly just note the solution to part B. And the solution to part B, let's return to the top of the page here. Part B is asking, what is the maximum torque you could apply? What is the maximum torque you could apply with this given force? How would you orient that force? Right. So this person is applying a 17 Newton force.